The foundation of modern physics is split in two. On one side, general relativity treats spacetime as a smooth, continuous fabric. On the other hand, quantum mechanics models our reality as a jittery swarm of quantized particles and fields. Both frameworks predict how the universe behaves with incredible accuracy. But when we try to use them together to understand the deepest levels of reality, like the center of a black hole, the math breaks. They refuse to communicate. To keep our cosmic equations from falling apart, we have had to patch the holes. We introduced dark matter to explain why galaxies hold together, and dark energy to explain why the expansion of the universe is accelerating. We can't actually see either of them. The time force hypothesis, or TFH, takes a different path. Instead of adding more invisible components to bridge the gap, it subtracts. It argues that the universe is built on far fewer ingredients. Rather than forcing incompatible theories into a compromise, TFH asks a radical question. What happens if we delete the concepts of space, time, and solid matter entirely, leaving only raw energy? Forget fixed space-time or solid particles. TFH proposes an energy-only ontology. It starts with a single, continuous, universal scalar field in a four-dimensional void. This energy propagates outward, creating a massive wavefront. This glowing 3D moving boundary is our observable universe, defining the present. This model entirely removes time as a pre-existing dimension. There is no timeline stretching infinitely into the past and future for us to travel through. Instead, physical time is strictly an emergent property. What we experience as time passing is actually just our localized clock, measuring how far that energetic wavefront has advanced through the void. We aren't moving forward through time. The present is a local experience, on the boundary of raw energy. This diagram maps the architecture of TFH. Looking at the central topography grid, we see how the theory accounts for gravity. As the wavefront pushes forward, it encounters energy concentrations. The front physically thickens and warps, explaining planetary orbits using only this moving energy. What we described as the curvature of spacetime is reinterpreted here as physical topography. Objects aren't following an invisible fabric, they are navigating the moving ridges and valleys of the energy front. The same logic applies to matter. In an energy-only universe, solid particles don't exist. The electrons and quarks making up our bodies are stable, localized vortex modes, rippling across the face of the wavefront. This entire system is regulated by a built-in friction called universal damping. It acts as a drag on the wavefront, constantly pushing the system toward equilibrium. This single damping effect drives the expansion of the universe and forward march of entropy. In this framework, gravity and matter exist as emergent behaviors of the wave itself, one representing the physical warping of the front, the other representing stable ripples on its surface. By grounding the expansion of the cosmos, the curvature of gravity, and the stability of matter in the movement of a single field, TFH provides a shared vocabulary for events across vastly different scales. Dark matter and dark energy emerge as predictable consequences of this scalar dynamics, manifesting as specific topographic variations and energy damping within the moving front. This blueprint illustrates the master TFH response chain, relying on strict falsifiability. To claim a physical effect is real, raw source activity must pass through this sequence of scalar deformation and response kernels. If the math breaks along this pipeline, the effect is discarded. This strict structure generates testable predictions. Because of that universal damping effect acting on the wavefront, TFH predicts a strict universal decoherence floor for massive molecules in quantum interferometers. It sets a hard lower bound on how long quantum coherence can survive. Second, the theory predicts microscopic specific shifts in the hydrogen 1s-2s energy transition, one of the most precisely measured quantities in all of physics. TFH leaves itself nowhere to hide. It relies on a small set of parameters that must accurately match these tightly constrained data points across different fields of physics, or the theory fails decisively. Even if the time force hypothesis eventually fails its empirical stress tests, its rigorous energy-only math forces us to reconsider our baseline assumptions. It permanently questions the persistent illusion that space and time are the core building blocks of the entire universe.